Hey Jessica, let's check this one out. Now here we have two radicals and we have this set equal to 1. So what we have to do first is pick one radical and get it over to the right side. So I did that here. I just added root x plus 3 to both sides. That canceled over here and brought it over. Then when I have only one radical by itself on one side of the equation, we can square both sides of this. So the square of the square root of x plus 4 cancels and we just get x plus 4. But over here, remember, this is a binomial now. So it's a binomial squared. We have to write it out twice, and then we have to FOIL it. So our first, 1 times 1 is 1 squared, or just 1. Our outside is going to be plus root x3 inside, plus root x minus 3. So we can combine those, right? Remember that when we're adding, we don't really mess with what's going on underneath the square root symbol. So we have root x minus 3 plus root x minus 3. We just call that 2. Root x minus 3. And our last is going to be root x minus 3 squared, and that cancels the root. We're just left with x minus 3. I took a minute and I combined some like terms. 1 minus 3 is minus 2, but then basically we're just going to get all this stuff over to the other side of the equation. So I add 2 to both sides to get rid of this 2. I added x to both sides to get rid of this, so I'm just left with 2 times root x minus 3. And that equals 6. 4 plus 2 is 6, the x's go away. Then to get this by itself, I divided both sides of the equation by 2. Canceling the 2 here, 6 divided by 3 is 2. To isolate just again that radical by itself. Once I'm there, I can square both sides of the equation. This cancels the radical, I get x minus 3 equal to 9. And then again, just adding 3 to both sides, 12 comes out to be the answer. Now remember, with radical equations, you always have to check. So I just blasted in 12 for x here and here, back up into my original equation. And 12 plus 4 is 16, 12 minus 3 is 9, square root of 16 is 4, square root of 9 is 3, 4 minus 3 does in fact equal 1. So I'd say we're good to go on that one. If you have any questions about that, feel free to let me know.